All right, so we're now bringing our two concepts together, this concept of inequalities, compound inequalities, and this concept of absolute value, and we're kind of meshing them together, right? And it seems like, okay, this is going to be more complicated. It's really not, because absolute value inequalities, you basically take the inequality and you convert it to a compound inequality. You just have to know which one to convert it into. Once you know how to convert it into a compound inequality, it's what we learned last week or 2 weeks ago, and it's the same thing all over again, okay? So there are some special cases, and we'll look at those, but for the most part, it's just about making the right conversion. If you can make the right conversion, then you're gonna be all set, okay? So our objective today is to be able to solve absolute value inequalities, and then we state the solution set in interval notation, right? So it's nothing new, right? Nothing necessarily new. So let's go here to type 1. And again, I'll explain the highlights, but eventually this will make more sense as we work through the examples. There's 2 types, and it's basically all depends on the inequality and where the inequality is pointing to. That is always the key determining factor as to whether you're going to convert it into the AND compound or you're going to convert it into the OR compound. Okay, so let's take a look at type 1. So in type 1, I want you to notice right here, we have your absolute value. Absolute value is by itself. And then you have the inequality, and the inequality points towards the absolute value. So it doesn't matter where the inequality, it doesn't matter where the absolute value is at, left or right. What matters is where is the inequality pointing to. If the inequality points to the absolute value, the way that this one does right here, right? Like if I made this an arrow, it's pointing to the absolute value. Therefore, this will be converted to the AND inequality, the AND compound inequality. So it's pretty simple. It becomes the AND sandwich. The same AND sandwich that we worked with last time. All you do differently now is you're going to add the same inequality over to this side, and then you see your C, it's a negative C. Okay, so you take whatever number would have been there, and again, I'll show you more in detail in the example how this works. Okay, but if the inequality points to the absolute value, it's an AND compound inequality. So we're going to make sandwiches. The second type is if the absolute value points away from the absolute value, right? So in this case, if you think of the absolute value as an arrow, it's pointing towards the constant that's on the outside, right? It's away from the absolute value. So then in this case, we convert it to the OR compound inequality, all right? Remember that when we have OR compound inequalities, we have 2 separate ones, and then we have the OR in the middle. So one of them will be the original. That's why I call this one the OG, right? So you see how it's just X greater than D? It's the same thing that you had above it, right? It's this same thing, except the absolute values are gone, right? So you have just X greater than D. Or, and then the second equation is one where you switch and flip, which means you're going to switch the inequality. So instead of pointing to D, now it's going to point to X. And then whatever the number or whatever the number is, you're going to replace it. You're going to put a negative in front of it. Okay, so it's a switch and flip. You switch the inequality and you flip the number from positive to negative. And that's basically what we do. All right, so we're gonna focus most of our time today looking at the AND compound inequality. And then probably next time we'll take a look at the OR compound inequality. All right, so for now, let's focus on where is the direction of the inequality pointing to? And then what does it look like when we expand it into the compound inequality? All right. So let's move over to example 1 here. All right, so taking a look at example 1. First thing is I want you to notice is you have your absolute value and then the inequality, right, it points to the absolute value. So the absolute value of X is less than 3. All right, now what does this mean and why does it convert into the AND compound? Remember what absolute value means. It means distance, right? So basically what we're saying is that the distance from X or the distance from 0 has to be less than 3, right? So that the distance away from whatever number has to be less than 3. So you can't be too far away, right? You got to be kind of like sandwiched in between, right? You see why it becomes a sandwich? Because your distance can't be too far, right? You can be like 3 spaces away at most, 3 spaces away in either direction, right? So that's what we're trying to say here. So the absolute value is pointing to the inequality points to the absolute value. So here's what we do. You drop the X, you copy the same thing that you have. Now, on the other side of the x, you're going to sandwich it. So you're going to use the same inequality, and then instead of 3, it's a negative 3 on this side. Okay? So what you just told me now, what you're saying is that the x value is stuck between 3 and negative 3, right? X has to be greater than negative 3, but less than 3, right? So my distance, right? My distance can't go too far, right? I have to be somewhere between 3 and negative 3, okay? So this is essentially what I mean about converting your absolute value inequality into just a compound inequality. And you just create a simple sandwich. Whatever this inequality is, it gets brought down, and then you basically copy paste it right next to it. All right. So that's what I mean with all that writing that I had there. Okay. So now that we have this, this is really easy to graph, right? Because we've done this before, right? So if we had 0, you had positive 3, and you had negative 3, right? At this point, hopefully we're a little bit more fluent, okay? But if not, we can just kind of recap. Notice that we have 2 inequalities working here. One says x is less than 3. So then at 3, it's an open circle, and you're shading to the left, all the way left. And then you have this other inequality right here, which tells us that negative 3 is less than x. We want to read it as x is greater than negative 3. Okay? So, open circle at negative 3, and x is greater than. Right? So where is the solution set happening? Remember, it's an AND problem, so it's the intersection. So we're looking at this part right here, right? So the overlap area, the intersection area, happens between negative 3 and 3. So then our interval will just be from negative 3 to 3. Open circles at both of them. So then it's parentheses around negative 3 and 3. Let's see. This part is OG, meaning like original. OG, original. And then this part down here is switch and flip. All right. Any questions so far on example 1? All right. So the example 1 was just like the real baby problem, right? That just kind of has us practice converting from an absolute value inequality to the compound inequality. And once it's compound, it's the same thing we've already learned. All right. So once again, we're looking for the intersection because it's a sandwich, it's an AND problem. So we want the intersection of both of those inequalities there. All right. So far, so good? All right, cool. Okay, now let's take a look at the OR type of problem. Okay, so I will do one OR problem today to show you the kind of basics, and then I will then proceed to move on with more AND problems. So with the OR problem, the OR type of inequality, the key thing is that now the inequality points away from 5. So what we're saying now is the distance, right? The absolute value, which represents a distance, the distance has to be greater than or equal to 5. So now it's like saying, I want you as far away as possible, and the closest you can get is 5 steps from where I'm at, right? So it's the opposite, right? When the absolute value is less than a number, yeah, basically, kind of, right? Like a restraining order. It's the opposite of what we want in the AND type problem. In the AND problem, I want you close. I don't want you to go too far, right? That's what your parents say. Don't go too far. And then when you get older, they're just like, stay away, like, get away, right? So the OR problem is essentially the restraining order. The closest you can come is 5, but you got to be like away from that, like further off from that. So the OR problem creates 2 scenarios, right? So it creates 2 different equations. The first one is what I call OG, original, all right? The original meaning you just bring down what you have, but no absolute value. So This is an OR problem. So we have x greater than or equal to 5, right? Notice how that's the exact same thing we had. Or now you're going to bring x, you're going to switch the inequality. So instead of pointing to 5, now it's going to point to x. So you switch this, and then instead of 5, it's -5. So this is where the flip comes in. So you switch the sign and flip the number from a positive to a negative. Okay? Does that make sense? Switch and flip? Or you can do switch, switch, or flip, flip, whatever works for you. But the idea is that you change the inequality and you change the sign of the number. So you have to do two things on that second inequality. Okay? So now I have both, right? Here's 1. Here's 2. And now we graph both, right? So what we should see is that the solution sets are far, like we're shading away from each other. It's like you could be 5 steps over there and further, or 5 steps over there and further, right? But don't come into my space in the middle, right? So that's typically what we'll see. So if this is 0 here, we have 5 here and -5 here, okay? With my first one, x greater than or equal to 0, that's a closed circle. And if I want greater than, x is greater than, then we're shading to the right. Second inequality, x is less than or equal to -5. So then at -5, closed circle. And now we're shading to the left. X is less than. So then I shade to the left. You see that? So it's like where you can stand is in the blue or the red, right? But there's like a distance between us, right? There's a gap. So from there, it's just about writing down the interval correctly, okay? And this is the part where I want to focus on to make sure that we're improving on this, because this is where I saw most of the mistakes, okay? When you're writing an interval, it's like you're reading a book from left to right, right? You're reading a sentence from left to right. Some of you guys are kind of flipping the order of your intervals around. Like you were putting the right stuff first, and then whatever's on the left, you put that second. So it's kind of awkward, right? So you're reading this number line from left to right. So you should be reading it from about as far left over here where the blue is at. And then where the end of the blue is at, that's -infinity. So you have to think that as like the start of your sentence. So the interval goes from -infinity all the way to where the blue stops, which is at -5. This should go first, okay? This should go first because you're reading from left to right. So then when it stops at -5, you put a bracket because it was a closed circle. Then you union, okay? Without the union, you're basically missing the point. The point of the union is saying is that my solutions belong in here or here. And I brought them together under this kind of hug of both of them are my solutions. But without the union, you're not expressing that mathematically correctly, okay? So you need the union. Some of you, that's all you needed, and that's where the mistake happened. Just remember, when you're doing an OR, you will need a union in your solution set, all right? And then it picks up again at 5, so bracket 5. Remember, see how I'm going left to right? Like as I'm going left to right, that's how I'm filling in my information. And then it ends all the way at +infinity. And there it is, okay? So that would be my interval, and that's my solution set, okay? Any questions about that so far? Right? So it's familiar. It's the same thing we've done. It's just, do I do compound and or compound or? That's it. All right. And then if you did want to kind of check, like, did I do this right? Did I pick the right, like, did I shade the right area? You can always test it, right? Let's say you pick a number over here, say -7. We take -7 inside the absolute value, and you test to see if this is true. If you get a true, it means you shaded the right section, right? So then absolute value of -7 is 7, and 7 is greater than or equal to 5. That's true. Therefore, it's okay that you shaded that section, right? But let's say you pick a different number. Let's say you would have picked 0, right? And you take 0, you plug it in here into the absolute value, and you're testing to see if you should have shaded that area where 0 is at. Then what you're going to get is a false statement, because 0, after it comes out of the absolute value, is still 0. That's not greater than 5. That's a false. right? So you can see that this section that's left blank is the reason why it's left blank, because it shouldn't belong to the solution area at all. Exactly. So numbers between -5, it's not that they're non-existent or not relevant, they're just not part of our solution, right? So we don't include them in the interval, we don't shade them. All right. In what cases would OR problems create a feasible region? You mean where the whole thing is shaded in? If the OR problems reversed, right? Let's say red went left and blue went right. And then not only and they overlapped, right? So whenever you have OR and they overlap, you're basically looking to see how much of my number line is shaded. Well, since the whole thing is shaded, then all real numbers. We'll see one like that. There's a special case like that later on. We'll take a look. I got you. Don't worry. All right, let's take a look at example 3. Here, it's just kind of stepping up the complexity levels. So first of all, I'm gonna leave it open just in case some of you are still copying. Absolute value of 2x plus 7 is less than 11. First thing you notice should be the inequality, where it's pointing at, okay? It's pointing to the absolute value. Therefore, what kind of inequality should I create? And or? It's an and, right? So you're gonna make a sandwich, all right? You're just building sandwiches here. So 2x plus 7 will be less than 11. What do I need to write on the other side? Yeah, I need the same inequality copy pasted, and then I bring a -11 over to the left side. Okay. So inequality does not flip. Notice it has stayed the same. Pointing left, pointing left, pointing left. Exactly. Right? So now we want to solve x. We want to get x by itself. So let's go ahead and do the math. We want to subtract 7 to all 3 parts of the inequality. So here it cancels. We're left with -18 is less than 2x, which is less than 4. Okay. Let's divide all 3 sides by 2. So we're going to be left with x is less than 2 and greater than -9. All right. So let's graph that out. So we have 0, we have 2, -9, right? Once again, you might be pretty good at this by now, right? You have your first inequality, which says x is less than 2. So open circle at 2, and you shade left. Your second inequality is telling you that -9 is less than x, which is also the same thing as x is greater than -9. Okay, so then at -9, open circle as well, and greater than, so you shade to the right. Okay, and now you're looking for that intersection. So that intersection happens right here in the middle for us. So we can then utilize that as our interval, as our solution set. So from -9 to 2. Okay. Notice how I'm not using like any infinities in this case because the solution set only happens between -9 and 2. So it's like it starts at -9 and it stops at 2. So your solution interval always is like a starting point and an ending point. Starting at -9, open circle, so parentheses, and then at 2, also open circle, so then parentheses again. And voila, you're done. You have all 3 parts, right? You have your inequality, you have your graph, and you have your solution set. Questions? Not too bad, right? All right, that's good. That's good. All right. All right, let's move on to this next example. All right, and I think it fits right there. Okay. All right, so example 4, right? Like I said, we're just kind of adding complexity to it to kind of get your comfort level so that you can kind of attack the problems no matter what you see, right? So just like when we were solving absolute value equations, the goal was get the absolute value by itself. Here it's no different. You want to get the absolute value by itself and then read what is the inequality saying. All right, so first let's get rid of all the junk, right? The 4, let's get rid of the -9, move that somehow to the other side so that we can get the block by itself. So if this is what I want by itself, what should I do first? Yeah, let's add 9, right? You have the ability to add a constant or subtract a constant. That's what you do first. So the 9, we add it over. Now we have 4 times the absolute value of 9 minus 3n is less than 84. Okay. To get rid of the 4, you distribute, right? Yeah, you divide by 4. Good, right? Remember, distribution is not possible into absolute value, all right? So we divide by 4. Very good. And now you're left with your absolute value of 9 minus 3n is less than, this will be 21. All right. Okay, so now, what are we going to convert this into? And or? It's an and, right? You want the distance less than 21. So you want to stay close, right? You want to stay close, sandwich it, all right? So let's sandwich this up. We have 9 minus 3n will be less than 21, but greater than negative 21, right? So I'm sandwiched between that negative 21 and the positive 21. The inequality, I kept it the same, right? Pointing in the same direction as the original, right? So copy paste and then negative 21 all the way on the left side. All right, so we got a little work to do. Let's do it. First, let's get rid of 9. That's right, okay? It's a positive 9. We want to subtract 9 from all 3 sides. All right. So let me zoom in a little bit here. Okay. So now we can get, that'll be negative 30, which is less than negative 3n, which is less than, is that 12? Yeah, that's 12. All right. And we can see here, we'll have to divide by negative 3 on all 3 sides. So now I'm gonna go up here now. This becomes positive 10. Because I divided by negative 3, what's going to happen to my inequalities? Yeah, we want to flip both, right? Because you divided negative 3 to everything. You flip the inequality for both sides. So now this becomes n, and this becomes negative 4. Okay? All right. So now let's read this. Okay, let's read this. I want to make sure we're shading in the right direction. So I have that inequality, which tells me n is greater than negative 4. All right, so let me graph a line here. I'm going to erase this for now. All right, so here's 0. Here's negative 4, and then we'll put 10 way out here. All right, so at negative 4, open circle, n is greater than, so let's shade to the right. Then we have the second inequality, which is telling us that 10 is greater than n, but it's also the same thing as n is less than 10. Okay. So now at 10, open circle again, and then you shade to the left because n is less than, right? So once again, our overlap area happens right here between negative 4 and 10. So from there, the interval is pretty simple. What's the starting point of the solution area? It's negative 4. The ending point of the solution area is 10. Because we have open circles at both locations, we have parentheses at both. Okay. All right. Questions on 4? So far, so good? All right. Good to hear. Good to hear. All right. All right. Now let's take a look at one of our first special cases. All right. This is one where anytime I like throw a special case at you, you want to think like, why? Like, why is he throwing this at me? Like, why is this going to be different from what we've seen before? Okay. And you want to think of it in all the different ways, right? What does absolute value mean? What does distance mean? Right? Can distance ever be negative? Right? Why is this somewhat of a strange inequality that I'm looking at? Right? How can distance be less than a negative value if distance is always positive? Right? So those are the kind of questions I want you to start like asking internally, right? Ask yourself. All right. So at example number 5, right, that's exactly the case. Right? I have the absolute value here of x plus 2, which is less than negative 7. So you might kind of like think to yourself, okay, it's pointing to the absolute value. Let me make a sandwich. But I want you to think first. Remember last time how we talked about absolute values, and let's say we had absolute value of x plus 3, and then the absolute value equaled like negative 2. What would we say like automatically from the jump without even having to do any work? Yeah, it would be no solution, right? Because we know that absolute value, whatever you get inside of that absolute value, will then become an output that is positive, right? Output that is positive. At best, you get an output that's 0, right? That's the smallest number you'll get when something comes out of the absolute value, right? It's going to be 0. Okay, so with that same idea, just think about what's going to come out of this. Absolute value of anything plus 2. What's the smallest number you think you're going to get out of that? Probably 0, right? Some decimal, maybe, right? But it's going to be positive. So it's either going to be 0 or it's going to be positive. Do you guys see that? Because I'm taking the absolute value of something, right? Some number, and it will either generate it as a positive or worst case scenario, it's going to be a 0. So you either have the scenario where you get 0 and you get this, or you get any positive number and then you get that. And what can you say about both of those statements? They're false. Exactly, right? 0 is not less than negative 7. And a positive number will never be less than negative 7 because positive is clearly bigger, right? So do you see how we've like gone through the only 2 options that we can have, and yet there's nothing that's going to work. There's no number that we could plug into that x value, take the absolute value, and then find out that it's less than negative 7, right? So you see the connections that can be made where absolute value equations, a lot of that kind of transfers over to absolute value inequalities, right? Because if I'm saying I want a distance, I want to keep a distance less than negative 7, like how does that make sense? If there was a negative on the outside, then we would have divided both sides by negative. We flip the inequality, the 7 is positive now, and then we can work from that. But because this is the equation that we have right now, we're just only trying to solve this, right? So we can't just magically like multiply a negative in there, hope for the best, all right? So this is what we have. So then in this scenario, you can get no solution as well, all right? But I wanted to kind of talk about it conceptually. I don't want you to try to solve problems like this because I want you to identify them as problems that would have no solution, because I cannot have something come out of my absolute value and then have that be less than a negative number, because absolute value will either give you something positive, right? You either get option A or you get option B. And either one of those options is not going to be less than negative 7. So then, because I can't solve that, I can't find a solution set for that. And it's just a no solution.